This is a review of 1.4 to 1.7. So we are starting on number 3. We're going to give the coordinates of 3 different points on this graph. So just analyzing the graph, pulling off the information. We have x and y, and in this case, we have our x and then the value of whatever the expression is here. That's what we're studying. So coordinates always come x comma y. And you've got tons of different options here. Any of these dots are fine. So let's start with this one. That's obviously 1, 1. So that order that you put those in is not significant because it's the same number. But let's skip over to, because you could do 2, 2 and 3, 3. But let's try this one out here. Make sure we know that x comes first. So the x value here is 4 and the y value, or the value of the expression, is 2. X comes first, so 4, 2. You put any of these. What about a negative? Make sure you still put the x first. That's negative 3. And then the y is negative 1. Okay, so now they're going to ask questions based on the graph. So they're either going to give you the x and ask what's the value of the expression, or they're going to ask you what is the value of the expression given x. Or vice versa. I don't even know if I said that right. But they're going to give you one or the other, and you just find the missing part. So what is the value of the expression when x is 4? X is 4. They've given you x. Okay, so you're looking for the other one, which is the value of the expression, or y. Anytime you see value of the expression, just think y. That's our y-axis. So x is 4, so go on your x-axis to 4. The only dot we have is here. What's the value of the expression? It's 2. So don't say 4, they already gave you the 4 part, so you're going to the y-axis and doing that. Now it says for what value of x? So we're looking for the value of x. They didn't give you x. They're going to give you the other thing. So is the value of the expression equal to 1? So right now y equals 1. You're looking for x. So go to the value of your expression, or the y, and go to 1. Okay, and there's two options here. We've got this dot and this dot. So what is the value of x? It's either negative 2 or 1. Number 6, for what value of x is the value of the expression also equal to x? So where is x and y the same? So what value of x is the value of expression equal to it? So we already saw this. We've got a 1, 1, where the x value and the value of the expression are the same. We've got a 2, 2. The x value and the value of the expression are both 2. We have a 3. It would fall on this line. Anywhere on this line, it's the same. You'd have negative 1, negative 1, negative 2, negative 2. The only 3 points we have are here, here, and here. So it's 1, 2, and 3. Okay, number 7. Xander's 3 years younger than his sister Yasmin. So if he's 3 years younger, so that means Yasmin is 3 years older. So if he's 5, she's 8, 6, she's 9, 7, she's 10, going up by 1. So this is 11, 12, and 13. And the ordered pair x comma y would be 5 comma 8, 6 comma 9, just combining these as an ordered pair. And now they want us to express Yasmin's age using x. So her age compared to whatever x is. So if it's 5, we know it's 3 more, it's 8. If x is 8, we know it's 3 more, it's 11. So you're taking whatever x is and adding 3. That's the value of the expression, whatever x is, plus 3. Okay, number 8, we're going to make a table and a scatter plot. Scatter plot is just a graph. And specifically when x is negative 1, 2, 3, and 4. So a lot of times students just get stuck with how do I start filling in this chart. The x is just the numbers you're plugging in, and here's the expression we're going to evaluate them for. So we're going to plug these numbers in and get the answer. Let's leave the negative for a second. Start with 4. 4 squared is 16. 4 times 4. Minus 3 is 13. 3 squared is 9. Minus 3 is 6. 2 squared is 4, and minus 3 is 1. Now negative 1 squared. Remember, anything squared means times itself. Negative 1 times negative 1 is positive 2. Okay, so positive 2. And when we go ahead and subtract 3 from that, we are going to get negative 1. Now, I know the answer key didn't say that. The answer key said negative. Oh, geez. 1 times 1 is not 2, right? What's 1 times 1? I'm thinking about the negatives and just going too fast. Negative 1 times negative 1, well, we know 1 times 1 is 1, not 2, right? That'd be 1 plus 1. So a negative times a negative is a positive 1. Minus 3 is negative 2. So our answer key was obviously correct. Okay, once we've filled in this chart, we're going to go ahead and put it on the table. So negative 1, negative 2, this is your x, and then this is your y value. The value of the expression is your y. So negative 1, negative 2. Now be careful, this graph on the y value counts by 2's. So when I go to negative 2, I'm just going down 1 actually here. 2, 1, go to x is 2. The y value of 1 is going to be right here between 0 and 2. So this is 2, 1. I have 3 and 6. That one has a perfect match. And then 4 and 13 is going to be between 12 and 14. If you tried to connect these, you would see that this does not form a straight line. And that is because of the x squared in the expression. It's going to create a curve, and we'll study these parabolas later. But this will not form a straight line when you have an exponent there. Okay, flip into the back. A little bit more on 1-4, specifically talking about what's the difference between real numbers and integers. So real numbers includes fractions, decimals, negative fractions, negative whole numbers, positive whole numbers. Integers is just 0, 1, 2, negative 1, negative 2. Okay, so integers includes negatives. Sometimes people forget that. But it doesn't include fractions or decimals. Real numbers include fractions, decimals, positives, negatives. Now this one says positive real numbers. So that wouldn't include these. These would be part of just the real numbers. So are these. Okay, it's not just the negatives, it's the positives, it's the negatives. But when we're looking at our multiple choice here, letter A, where it says positive real numbers, then we would obviously not use a negative. So we're going to look at specific situations and think about what's the best types of numbers to represent them. So number 8, the number of yards gained or lost in a football game. So I actually, when discussing this, I always kind of butt up. It's not a great example. If you look at the answer key, they said letter C. So they say letter C because integers include positives and negatives. If you lose yardage in a football game, right, it could be negatives. And usually yardage is going to be expressed in whole numbers, but you kind of got to be deep in football to understand that. But realistically, when you're playing football, are you always going to gain exactly 1 yard or 2 yard or 3 yard? There is the possibility to gain a half a yard, but I also know, as someone who follows football, that they normally don't express yards gained for a quarterback or a running back as a decimal or a fraction. It's usually a whole number. So that's why it's integers. But if you wanted to argue that you could gain a half a yard in positive or negative, and I wouldn't argue with you because I see that. So just knowing that yardage is in a football game and the stat sheet is always expressed as a whole number, then we know it's integers. But realistically, you're not going to physically gain exactly a yard, 2 yards, 3 yards. There's decimals in there. So B would also make sense. Number 9, temperature outside today. So we got positive or negative, right? Could be. And is it always going to be a whole number? No, it could be 74.3 degrees, something like that. So this is all your real numbers, fractions, decimals, positives, negatives. That's letter B. And number 10, your height. So your height's not going to be a negative. Your height's going to be only positives. Your height is not always going to be exactly 1 foot, 2 foot, 3 inches, 4 inches. Okay, you're going to be in between. So this is our positive real numbers, fractions, decimals, no negatives. Okay, number 11, we're going to use the graph below. We're talking about students on a field trip and how many chaperones have to go with them. So we're going to give the coordinates of R first of all. So always expressing your x value, which is your number of students, first. So 60, 3. Number 12, we're going to describe the situation that corresponds to this. So cool, we pulled those numbers off the graph from that point, but can we make sense of it for the specific situation? So what does the 60 represent? What does the 3 represent? So you can say for every 60 students, there's 3 chaperones, or you could say 3 chaperones for 60 students. Okay, we're just putting some context. That's the word I'm going to use a lot for those types of questions. We're going to put some context to the numbers, because numbers are just numbers, and if we don't know what they represent, they're not very helpful. So some context. What's the 3? What's the 60? And then we're going to explain why the domain of n is the set of positive integers. So we're talking about people, right? This specific situation, the context of the situation. It's talking about people. So no negatives, no fractions. We're not going to say 3.4 people attended the trip. The only way we ever talk about people like that is if we're talking about an average. This is talking about a specific number of people. So no fractions, so we're talking about integers, and it would be positive integers because when we're talking about how many people went on a trip, we're not going to talk about negatives. Okay, down to 14 and 15. 2 different situations. First one, you have a bus ride, it costs $11, and then $2 for every piece of luggage. X is going to represent how many pieces of luggage. And then number 2, you're at an internet cafe, which now sounds kind of silly, but when this book was created, that was a thing. Internet cafe, the cost to use a computer is $10 for the first 30 minutes. So you pay $10, you get 30 minutes. And if you go over 30 minutes, you pay 50 cents for each minute after that. X is going to represent the number of minutes after the first 30. So which situation does it make sense to have an X value of 32.5? So 32.5. We'll go check what does X represent. X is your pieces of luggage. X is your number of minutes. Does it make sense to have a half of a piece of luggage or a half of a minute? So half of a minute, obviously. You're probably not putting 32.5 pieces of luggage on your airplane, but you could go over your minutes at this cafe by 32.5 minutes. That makes sense. So now go ahead and find the cost of the situation. So we have $10 for the first 30 minutes plus 50 cents per extra minute. So the extra minutes was 32.5. So we're going to go ahead and multiply 50 cents, 0.5 times 32.5, get 16.25, so $16.25 plus the initial $10 for the first 30 minutes gives us $26.25. Okay, we're now looking at absolute value from 1/6. The basics of absolute value is it turns whatever's inside positive, the final value positive. It's asking you, what it's actually doing is how far is this as a distance from 0? So how far is negative 89 from 0? It is 89 units. But basically what happened? The negative became positive. If it was already positive, it stays positive. What happens when there's a negative on the outside? It's going to stay. So my answer here is going to be negative. First thing I got to do is find the answer here. And I don't go in here and make everything positive. I don't make this a plus and this a plus. You answer the question. You evaluate the expression. If it's negative in the end, you make it positive. This negative, though, will stay out front. So negative 16 minus 4 is negative 20. So here's what I'm left with as I start to simplify. Negative 20, when you take the absolute value, becomes positive 20. But this negative hangs out on the outside still, hasn't gone anywhere, not affected by the absolute value. And so my final answer here is negative 20. Try and take a look at number 3 and absorb everything you see before you start. I've got an absolute value on the outside of all of this, kind of like parentheses on the whole thing. So I know this answer will be positive. Then I also have 2 separate absolute values on the inside. So first of all, this negative 73 will become positive, minus. When I multiply here, inside the absolute value, I get a positive anyway. Negative times negative is positive 16. And when I take the absolute value of a positive, it stays positive. So it's still 16 minus 100. So I'm going to do all this math, 73 minus this minus this. So I know that I'm going to get a negative answer inside of this because 73 minus something minus 100, that's going to give me a negative. But absolute value will make it positive. So my final answer will be positive. So 73 minus 16 minus 100. It's negative 43. So I have negative 43 inside the absolute value still. Final answer then becomes positive 43. Okay, number 4, I see a negative out here outside of absolute value. So whatever's on the inside will become positive, and this negative will make it negative. So I know my answer is negative. So I also have 2 sets of absolute values. Now, whatever I get in here is going to be positive, but then this negative will turn it negative. But all of that is also inside absolute value. So that's going to end up being positive. So this negative out here really doesn't matter because, yeah, it makes this negative, but then the absolute value makes it positive. This negative will carry through. So let's just go ahead and run the numbers here. 8 times negative 2 is negative 16 plus 20. That's positive 4. So I'm going to have positive 4 in here. Absolute value of positive 4 is 4. Becomes negative, but the absolute value out here makes it positive. This negative holds true. So a lot of things kind of cancel themselves out. Negative 4, final answer. Okay, number 5. We're evaluating for this when w equals negative 80. So it doesn't matter what w is. It's inside the absolute value. It will become positive, and the negative will stay here on the outside. So when I put negative 80 in, absolute value makes it positive 80, but the negative out here stays. Final answer is negative 80. All right, I'm doing y minus x and then taking the absolute value. So it's 27 minus negative 2.4. Well, when I minus a negative, it goes plus plus, so it's like adding. So it's 29.4, and you take the absolute value. It's already a positive. It stays a positive. Final answer. All right, we're plugging in negative 49 now in both of these spots. Let's analyze this, though. When I plug it in here, it's inside absolute value. So that negative 49 will eventually become a positive 49. This A, I have negative 49 minus 49. So be careful. At first you might say, oh, that's 0. But negative 49 minus 49, you're already in the negatives and you're going farther down into the negatives. Minus 49, that's negative 98. All right, so I have all of this. I have a negative out here. I get negative 98 here. The absolute value makes this positive, but this negative will stay there. So the final answer is negative 98. And then number 8, a little tricky. We start dealing with some fractions here, but I would just encourage you to use a calculator for these. Scientific or graphing calculator will handle your fractions. So I'm going to rewrite this one down here. So it's going to be negative 5/8 plus 6 inside the absolute value minus m squared. So I'm going to put this in parentheses, 5/8 squared. We want to make sure that the whole fraction is squared. Plus 3, all that inside absolute value. Okay, so let's take a look at a couple different calculators. If you have a graphing calculator, the shortcut to a fraction is alpha x. You can go into math, or there's lots of different ways to get there, but alpha x is the shortcut to bring up a fraction. We're going to get good at pulling that up. So we'll put a 5/8. And if I want to square it, I can hit squared like that. And think about it, it's times itself. It's 5/8 times 5/8. And so you're multiplying straight across. So you get 25 on the top and 64 on the bottom. So that's what happens here. 25/64 plus 3. So let's go ahead and take this and go plus 3. And so we're going to get 217/64. It's inside the absolute value, so it becomes positive. It's already positive, so that's good. So all we need is this now. So negative 5/8 plus 6 gives me a positive 43/8. So I'm taking 43/8 and I'm minusing 43 over 8 minus 217 over 64. Final answer, 127 over 64. That would be a lot of work if we were doing all of this by hand, because remember, when you're combining fractions, you need common denominators. So this 8 would have to become a 64. You'd have to multiply both top and bottom by 8 before you can actually start subtracting your numerators. Not expected right now. We're just using calculators. Just remember, on this type of calculator, which is probably more likely what you have at home, you're going to use the ABC button. And it's going to give you your answers a little bit differently. So let's look at that real quick. 5/8 like this. If we hit squared, we get 25 over 64. So there's that. That's good. Plus 3. Now, here's where it's different. So our last calculator gave us 217 over 64, and this one gave us 3 and 25/64. These are the same thing. In elementary school, middle school, you practice turning fractions, improper fractions, into mixed numbers. These are equivalent, so you could use this. And then over here, same thing. You're going to have negative 5/8 plus 6. So you're going to get 5 and 3/8. So you'd be minusing from that 3, hit the ABC button, and 25/64. You get 1 and 63/64, which is the same thing as this. Okay, so these are equivalent. Both of these answers are fine depending on the calculator you have. You also could have tried to convert these things to decimals. 5 over 8, 5 divided by 8 is 0.625. So that is a concise decimal. It actually doesn't go on forever, doesn't repeat, doesn't end. So you could have used that decimal and got the decimal version as well. So the equivalent decimal version, if I divided 127 by 64, is right here. So this answer is also fine. Although I'd rather not deal with this, I'd rather deal with the fraction. But depending on the calculator and the situation, this is fine. Okay, so lots of different ways to give an answer there. I don't want you overly confused. It's kind of like a little challenge question. If you can understand 1 through 7, 8 is just taking it to the next level. In terms of what would you be quizzed on, you're just looking at the basics. Okay, we did not have to do the bottom here, but we could have analyzed 11 and 12 even without looking at anything else. So we skipped 9 and 10. Oh, okay, so I was looking at this like that was related to 9 and 10. So number 11, state whether this is true or false. So plugging in any number for x, whether I plug in 1 or negative 1, it's going to take the absolute value, and so it's going to become positive. This one's going to stay positive. This one's going to become negative. So this would be false. Now, on the answer key, start talking about graphs. You don't even have to say that. You could give an example. You could say the left side is positive because I take the absolute value and there's nothing else. And the right side of the equation is negative because I'm going to take the absolute value of whatever it is in here, so it becomes positive, and the negative will stay. So I know this is not ever going to be true here, unless you plug in 0. And number 12, are these going to be equivalent? So you're always multiplying by 3. When I say always, I'm looking at the two sides of the equal sign. Are these equivalent? It's going to be 3 times absolute value of y, 3 times absolute value of negative y. So regardless of what I put in for y, whether it's a 2 or a 5 or a negative 5 or a negative 10, if I put in a negative 10, by the way, here with a negative, it would say negative 10, which would be positive 10. But in the end, you're taking the absolute value of whatever it is in both spots, and it's going to become positive. So whether it's a 2 or a negative 2 that you plug in, after absolute value, it'll be positive times the 3. This is going to be true no matter what number you put in. All right, last page. Looking at mean, median, mode, and we did not have to do the bottom. We're just looking at 11 and 12. Okay, so we're looking at some math scores and some English scores here. We're looking at the mean, and then mean absolute deviation, And then we're going to talk about how do we use that mean absolute deviation to analyze consistency. So first, let's find the mean. So each set. So first of all, we have 1, 2, 3, 4, 5, 6, 7, 8 scores. So we're going to add them all up and divide by 8. 1, 2, 3, 4, 5, 6, 7, 8. So both of these are out of 8 different scores. Let's add them up separately. So just the math first. So I got 666 divided by 8. So 83.25 for math. For test average, that's what the mean is. Okay, in English, we do the same thing. Add them up, divide by 8 because there's 8 of them. That's 706, so a bigger number, which means her grade's going to be higher. Divided by 8, 88.25. It's a little bit higher grade in English. Now we're going to calculate the mean absolute deviation. So here's where there's a lot of work. So we go back, we'll do math and English separately. You're going to find out how far off each one of these scores was from her average. So you're subtracting the difference between the two. So 75 minus 83.25, 77 minus 83.25. You get 8 new numbers. We're going to take absolute value. We're just looking at the distance. How far away was it? So we're not going to express any of these as negatives. And then once we've got all these new numbers, find the average or the mean of those, and we'll talk about how we can use that number. So let's start with math here. We're going to get 8 new scores. So first, 75 minus my average, 83.25. And again, we don't want a negative. We're just expressing this as a distance. So 8.25. Then 77 minus 83.25. 6.25. No negatives. 82 minus 83.25. 1.25. 91 minus 83.25. 7.75. So far I've got 4. I got 4 more to go. 81 minus 83.25. 2.25. 3 to go. 82. 1.25. 92. 8.75 and 86. 2.75. So each one of those numbers represents how far off the individual scores were from the average. The average is kind of your middle score out of all of them. Some of them were a lot farther off. The 75 was pretty far off from his average. And what's the highest score? 92 is also going to be high off his average. And some of them are closer to his average. So you could have a student that averages the same thing, has the same test average as Jenna, but they could be more consistent. They could shoot right around that 83.25 every time. Go 83, 82, 84, but get the same test average, where this person is up and down and all over the place. But in the end, they all average out the same. But those are two different students, and those have to be expressed differently when we're looking at mean absolute deviation. So we're going to go ahead now and find out what's the mean absolute deviation for his math scores, or her math scores. So we're going to do the same process we did here. Now you just find the mean of these new numbers. So you're going to add them all up. There's 8 of them. We're going to divide by 8. So 8.25, 6.25, 1.25, 7.75, on and on. Add them up. You get 38.5. Now we're averaging these. So just take a look at them real quick. Our lowest is 1 and our highest is 8. And then we've got stuff in the middle. So it's going to be somewhere in the middle of all that. So divide it by 8. And we get 4.8125. Come back to that in a second. Let's run the English numbers real quick. So those we're comparing to the average of 88.25. So we're going to have 8 of those. I'm going to put them down here. So 87 minus my average of 88.25. No negatives, just how far off. What's the distance expressed as a positive number? And let's be careful. It's easy to run up and grab the wrong numbers. So we did 87. 82 minus 88.25. So 6.25. Did 89, 93. Okay, I did 93, 90. Okay, I did 90, 85. No negatives. So I've done 1, 2, 3, 4, 5, 6. 2 more left, so 89. Real close to the average, 0.75 off. We already did that over here, 89. And then 91. 2.75 off. Okay, so now we have to average all of these out. We're going to add them all up and divide by how many we have, which again is 8. So adding all of these up. So 21.5 is my total, and I'm going to divide that by 8. And my English mean absolute deviation is 2.6875. So both of these are averages, and it's not our test average. So the test average was 83, test average was 88. These averages are telling you how far off was each one of their individual scores from their average. How all over the place are they? So when we go to letter C now, in which subject are the scores more consistent? That comes from a lower mean absolute deviation. So when I compare these two, English has a much lower mean absolute deviation of 2.6 compared to the math of 4.8, which means his math scores were more inconsistent. They jumped all over the place, some high, some low. And if you just look at it, we had an 8.25, 8.75, 6.25. That's how far off he was from his average. A couple times he was close, 1.25 away. But if you look at the English scores, the farthest they were off was 6.25, so not 8.25. And we had a 0.75, we had a 0.75. So they were consistent. On average, they were closer to the middle, the test average. So who is more consistent? The lower mean absolute deviation would be English. Okay, we're going to do the same thing here now on number 12. Calculate the mean absolute deviation. Who's more consistent? That's going to come from the lower mean absolute deviation. So let's start with the mean. We're going to add these up, divide by how many we have, which is 1, 2, 3, 4, 5. So we're going to divide by 5. So first thing we're going to do is add them up. Okay, I got 58.96. 5 scores, so divided by 5. And your average should always be in the middle of all your scores. So if I thought I had my calculations right, but then my average was like 8. But look at all her times here that she ran. They're all 11 point something. So how can her average be 8? It wouldn't make sense. So you can always double check yourself. Abby's average time is 11.792. And then CJ, same process, 1, 2, 3, 4, 5. So we're adding 5 up and then dividing by 5. So 59.07 divided by 5, 11.814. That's their average. And now we're going to find mean absolute deviation. So how far off was each one of their times from their average? So we're going to get 5 new scores for Abby. I'll put them right above it. So everything's based off her average of 11.792. So I'm going to subtract all of them. 11.64 minus her average of 11.792. Not worried about negatives. So this is a 0.152. Next one. 11.83 minus her average, 11.792. So that one's off by 0.038, really close to her average. Let's make sure I write those neatly so when I have to punch them in later, I can do it correctly. 11.7 minus her average, 11.792. Whoa, that's really close. 0.092. 11.92 minus 11.792. This one's a little farther off. 0.128. And the last one, 11.87 minus 11.792. 0.078. So now I know how far off each one of these times was from our average. I'm going to add these up, divide by 5, and average those numbers out. So it's like a second average, basically. So 0.152 plus 0.038 plus 0.092 plus 0.128 plus 0.078. And there's 5 of them, so divide by 5. And so Abby's mean absolute deviation is 0.0976. All right, kind of tedious. Almost done though. So CJ's now, we're going to subtract all his times. So 11.81 minus his average, 11.814. Wow, really close. 0.004 off. Super close. 11.86 minus the average, 11.814. Kind of close again. 0.046. 11.73 minus the average, 0.084. Point 0.066. And 0.024. So just looking at those, I can already predict who's going to have the better mean absolute deviation. Look at this, 0.1 off, 0.1 off. All of these are 0.0 something off. So CJ's times are all much more clustered together in the middle. They're all very close to his average, so he always runs very close to the same number, where Abby is kind of more all over the place. So let's go ahead and calculate the mean absolute deviation though. So we're going to add those up, divide by 5 because there's 5 of them. 0.004, 0.46, 0.084, 0.066, 0.024. Okay, so that's all of them added up. Divide it by 5. CJ has a mean absolute deviation of 0.0448. So on average, he's off from his average time of 0.04. Okay, so out of these two, comparing numbers, well, we've got decimals. So you look at the first decimal place, they're tied. Second decimal place, CJ is lower, so his number is smaller. Or her number, I guess. They're both girls here. Which girl is more consistent, meaning runs closer to their average? Smaller mean absolute deviation will tell you. Justifying means actually explain that. So without just guessing that it's CJ, how do you know? Justify. She has the smaller mean absolute deviation.